Good morning and welcome back. Today we are going to learn about slope. So this will be our introduction to slope. And this we will also learn how to find slope using a graph. So using the graph to find the slope visually, also learning what slope is, because this might be our first time learning about it. So before we get into the bulk of the lesson, I want to go over a definition. And the definition I want to go over is a ratio. What is a ratio? A ratio, simply put, this might be a review for some of us, this might be brand new, don't worry. A ratio, simply put, is a comparison between two numbers. Oftentimes, when we're learning about ratios, we tell you something like George has 6 apples and 5 bananas. And we ask you to find the ratio of how many apples to bananas that we have. And we tell you can write it in one of 3 ways. You can write it with a colon, 6 apples for every 5 bananas. You can write it with a word, with the word to, 6 apples to 5 bananas. Or you can write it as a fraction, 6 apples to 5 bananas. And usually that's about as far as we go with ratios when we're first learning about them. Today we're going to get a little bit deeper in them. And the thing to remember about today is that we are only working with ratios represented as a fraction. We are no longer using these formats, so 6 to 5 or 6 to 5. Oops. We are only using our fraction today. A next term that I'd like to go over is our rate of change. This is kind of a new, very serious math term, but it looks a lot scary than it is. A rate of change, simply put, is a ratio. So we'll start there. So it's a comparison between two numbers. It is a ratio that shows how one variable changes with respect to another variable. So to use our example up here with our 6 apples and our 5 bananas, a way that we can represent this is if I tell you, oh, well now George has 12 apples, and I want you to tell me how many bananas he has. And we know that ratios, we can only transform them using multiplication so that they remain proportional. So we can go and we can look and look at the difference between 6 and 12, and we think of the relationship between that, the multiplicative relationship between 6 and 12, and we look at our multiplication table, or we know our multiplication facts, and we say, oh, 6 times 2 is 12. So we know that we're multiplying by 2 to get our 12. And then we go over here and we say, oh, well, I'll just do that to the other side because that's the math rule generally. And I know that 5 times 2 is 10. So my apple is one of my variables and my bananas are another one of my variables. When I change my apples and I say, oh, 12 apples now, no longer 6, now we have 12, then my bananas are also going to change, and they're going to change proportionally. And that's why I used multiplication here. So if George had 12 apples, George also had 10 bananas. Or we could write it like this. Or we could write it as a fraction. Run out of room over here. I'll go all the way over here. As 12 to 10. So our rate of change, just to use that example, so it's a ratio that shows how one variable, like our apples, changes with respect to another variable, like our bananas. So in this example, actually, we're trying to determine how the bananas have changed with the apples. But it can kind of work either way. It just kind of depends on the situation. Our next math term today is kind of the big guy, the big meat of the lesson, and that's our slope. This is our new term. Before I give you the mathematical definition, that's probably not going to make a bunch of sense to you right away because it's weird and new. I just want you to take a second, and I want you to think about the word slope, and I want you to think about what comes to mind when you hear the word slope. For me, what comes to mind when I hear the word slope are mountains riding the slopes. And that might just be because I grew up in the Rocky Mountains, but it also might be because I have a lot of friends who like to go skiing and snowboarding, and they say, oh, I'm going to go hit the slopes. I'm going to slide down the mountainside at very high speeds, and it's going to be really fun. That's something that I think about when I think of slope. I also think of when they take me along skiing or snowboarding, and they're going on these very, very scary runs, but I am on the bunny hill. I'm going up a little bit, and I'm going down not very fast at all. I'm just hanging out on the bunny hill, going slow, because I'm not very good at sports. So those are two things that I think about when I hear the word slope. I also think about, because I'm a math teacher, I think about how I explain slope to my students. And a word that I use a lot is the slantiness of a line. I can also use the word steepness of a line. Sometimes that makes sense for some of us more than slantiness. And that just basically means, is it really steep? Like over here with my super cool friends who've been skiing and snowboarding since they were small, and they slide down the mountain at high speeds, and they're going down very steep hills? Or are they going down not so steep hills like me on the bunny hill, going slowly because I did not grow up skiing and snowboarding? Mathematically, when I think of slope, when I think of how I would explain it if it were in a math book that was getting published by Rene Descartes or anybody, I think about the definition of a slope a little bit differently. I think about the slope as a ratio, another comparison between two numbers of the vertical change, also known as the rise when we're in math class and we're learning about slope. So the ratio of the vertical change to the horizontal change. When we talk about horizontal change in math class, we often call it the run. The ratio of the vertical change to the horizontal change between any 2 points on a line. And that's our mathematical definition. So we can say, oh, up here it looks really steep and slanty, and over here it looks not very steep and slanty. But that doesn't really fit in a math class so much as it does a ratio of the vertical change or the rise to the horizontal change or the run between any 2 points on a line. Something else specific about slope when we're talking about it mathematically is that the ratio that we found between any 2 points of a line will stay the same, or a math word, so will stay the same. Sometimes in math, instead of saying stay the same, we say will remain constant for any 2 points on the same line. On the same line. And that's probably feeling a little scary right now, so I'm going to give you a little doodle to show you what I mean. So here's a line, and I can pick any 2 points on this line that my heart desires. I can pick this one and this one, or I can pick this one and this one, or I can pick this one and this one, or I can pick this one and this one. And all that it means is that the ratio between the vertical space and the horizontal space, or the rise over the run, these will always end up being equal no matter which points I choose to pick. That also might not make a ton of sense right now. Just stay with me. We'll do some examples and it'll make a little bit more sense. Another specific thing about slope is that slope is always written as a ratio. Or is always written as a fraction. Of course it's always written as a ratio. It's in the definition. It's always written as a fraction in simplest form. Simplest form, when we were younger, sometimes meant a mixed number, but in here, simplest form, all we're going to do is reduce the fraction. It can stay as an improper fraction, or it can stay as a reduced fraction. We'll get more into that a little bit later as well. The thing that we don't want is we don't want 2/4. We don't want that. We want to take our 2/4 and we want to reduce that down to the simplest form that we can, which would be 1/2. And then finally, slope is represented by the letter M. And nobody really knows why. There are some scholars that say, I think it's a French word, that it comes from the French word monter, which means up. There are some other scholars that say it comes from the Greek or Latin word modulus, which means change, but we don't really know, and we have just accepted that slope is always M. It doesn't make a lot of sense all the time. However, that is one of the things that we do just have to accept, is that slope is M, and there's nothing we can do about it. There are 4 types of slope for our purposes. If you get into calculus and like linear algebra and some higher types of math, there might be more types of slope, but right now, since we're just learning it, we only have 4 types that we need to remember. Let me draw a table. I am not an artist, I am a mathematician. So 4 types of slope. First type of slope that we have is positive slope. I have found that when we're determining if it's positive or negative just by looking at it, I like to think of it as we are going uphill if it's positive. And by uphill, I mean if we're looking from left to right, it looks like we are on the ski lift. Let's see if I know how to draw a ski lift. So I've got wires, I've got some chairs, and I've got a dude ready to shred. But we're going uphill from left to right. So positive plus uphill, whichever way you want to go. We also have negative slope. And negative slope is the opposite, and it is when we are going downhill. It is when we are actively shredding. We are going down the mountain. We are going at incredibly high speeds that may cause injury. We are going down from left to right. So if we look from left to right, we are going down the hill. We have some extra special types of slope too. We have our zero slope. And that is just a nice little walk in the park. Just hanging out. We're walking. Having a good time. On a stroll. Another way I like to remember that this is zero slope is that I look at this and I can just keep going and make a Z. But first I like to think of it that we are just walking on flat ground. We're able to walk. We are not stressing. We're not going up a hill. We're not going down a hill. We're not hurting our knees. We are just walking. And then finally, we have undefined slope. Sometimes you'll also see this as no slope, which can get a little confusing because 0 feels like nothing. So when in doubt, we can use the term undefined. And that is a line that's straight up and down. That is a line that we would need special equipment to climb or to walk on, or special parkour skills, or what have you. I'm not qualified to climb this hill. That doesn't even look like a hill. That just looks like scaling a building, so I'd need special equipment for that. That another way I like to remember this is this vertical line looks like the beginning of a U, which we will then spell undefined incorrectly, it seems. Looks like a U, and we can write undefined. And that's one way that I like to remember that too. So positive, going up the hill. Negative, going down the hill. 0, just walking along, just walking on the sidewalk on flat ground. And then undefined is I need special equipment to scale it. Is how I like to remember those. What does it mean? It's a great question. I would love to tell you. Here are some examples that I'd like to go through with you. So the first thing that I'm going to do is I'm going to look at this graph and I'm just going to start noticing some stuff. So the first thing that I notice, because I'm a math teacher, is that my axes are not labeled, and that bothers me. So I'm going to go ahead and label those. The second thing that I notice is that it's on a coordinate plane and that there's a line on it. It's the second thing that I notice. The third thing that I notice is that there are these points already so conveniently located for me. That's going to be really helpful for me trying to figure out the number value of how slanty this line is. I think that's everything that I notice. So I'm going to go back up to my notes and I'm going to look at what slope is. My slope is the rise over the run. The vertical change, the ratio of the vertical change to the horizontal change. So it's going to be M equals rise over run. Or my vertical change over my horizontal change. And then what I like to do when I'm doing these is I like to, let me get a different pen color. Let's do yellow. Let's make it big. So the first thing that I like to do is I like to kind of draw a triangle so that I can see my space a little bit better. So I'm going to go from this point. I'm going to go vertical as far as I can until the next point. And then I'm going to take this and I'm going to find my horizontal space as well. See what I did there? So I traveled up and then I traveled over. And then I'm just going to count the space in between it. So let me go back to my other pen color. I'm just going to count the space. So first I'm going to find the rise. And rise means vertical. So I'm just going to count how many spaces I traveled. 1, 2, 3, 4, 5, 6, 7. So my rise is equal to 7. And my run, what on earth? Let's draw my triangle back again. Technical difficulties, please stand by. Okay, so I counted my vertical space. I went 1, 2, 3, 4, 5, 6, 7. Now I'm going to count my horizontal space. So I'm just going to go 1, 2, 3, 4. So my rise is 7 and my run is 4. And then the last thing that I do is I make sure that that's the right number. So I'm going to see if it's I'm going to see if it's a positive slope or a negative slope. And when I was learning these, I just kind of looked at my pictures to see if they went the same way. And then, so I'm going to look here. I'm looking from left to right, and I see that it's going uphill. So I'm going to look up here. Oh, this is going uphill. So it will be a positive slope. So my M is the same as 7 over 4. Positive 7 over 4. So I traveled up 7 spaces and I traveled to the right 4 spaces. Easy. Let's do another one. So I've got my rise over run. Let's write that down. So M is equal to rise over run. And here, I'm going to notice some more things. I noticed this point, and I noticed this point, and I'm just going to count the vertical space and the horizontal space. So I'm going to make my little triangle, connect these 2 points. If you like to think of the triangle, the one thing that matters is that it should always be a right triangle. You should always have a square angle. Okay, so now I'm going to look at my rise, or my vertical motion, or my up and down motion, and I'm going to count. 1, 2, 3. My rise is 3. And then my run, or my horizontal motion, or my left to right motion, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So right now I have 3 over 9. The next thing I want to do is I want to see if this is positive or if it's negative. So I'm going to look from left to right, and I see that it looks like we're going downhill. I could draw my little ski dude, and he's shredding the gnar. He's going downhill from left to right. So I know that that is going to be a negative slope. If I didn't know that, I could look back up at my little picture, and I could see that these are slanting in the same direction. So I know that that's going to be negative. And we're still not done here, because the last thing about slope is that it is always written as a fraction in simplest form. And this, unfortunately, is not in simplest form. So I'm going to go ahead and reduce that. To reduce that, I'm just going to divide it by my greatest common factor of these two numbers, which is going to be 3. If I didn't know that, I could go out and I could list all of the factors of each one. So factors of 3 are 1 and 3. Factors of 9 are 1 times 9 is 9, and 3 times 3 is 9. So I know that that's my greatest common factor. I'm just going to reduce that. I get negative 3 divided by positive 3 is negative 1, and then I get 9 divided by 3 is 3. So my slope, my ratio between rise and run, my ratio between vertical space and horizontal space is negative 1/3. This is also a really good example to pick some different lines, points on the line, and see if I still get the same slope, because this is a big line. So I'll pick this point, because it's nice, it's already there. I'll also pick this point, and I'll do the same thing. I'll draw my little triangle. I go boom and boom. I'm going to count my vertical space. I see 1. I'm going to count my horizontal space. 1, 2, 3. 3. So my rise is 1. My run is 3. I know that this is a negative line because we already did it. And I got the same answer both times. Even though I picked different points, because they're on the same line, since a line is straight, it will be the same amount of slanty no matter where you try to calculate it. Let's do another example. What on earth? This is a horizontal line. I can't really make a triangle, but I can make a line. So first let's try to find my rise, my vertical motion. I don't see any vertical space here. I see a point. That's it. So my vertical space here is going to be a 0. And then I can count my horizontal space. 1, 2, 3, 4. I can get 4. So my m is the same as 0 over 4. Or my m, my slope, is just 0. And you don't have to calculate that as long as you know that. We look over here, I see my vertical line, or my straight line horizontal that I could walk on is 0 slope. I could just say that it's 0. I didn't have to do all that. And the same one here. This is a vertical line. I see 2 points. I don't see any horizontal space. I don't see any run. So let's see. So if my run is 0, my rise is 1, 2, 3, 4, 5. I don't think I'm allowed to have 0 as a denominator ever. I think that's mathematically illegal, because that's the same as like dividing by 0, which I can't do. So we don't write a number for this. We write that this is an undefined slope, because I would need very special equipment to try to scale this wall. Great. So horizontal lines are 0 slope. Vertical lines are undefined slope. Great. Okay, let's do some more examples. Great. So let's find the points on this one. Let's decide if it's positive or negative. So I look from left to right. It looks like I'm going up the ski lift, so that'll be a positive. So that's easy. I'm going to draw my triangle, and then I'm going to calculate my rise over my run. My rise is my vertical space. Let's count. 1, 2, 3, 4, 5. And then my horizontal space, let's count. 1, 2, 3. So my slope is equal to 5/3. Am I allowed to have improper fractions when I talk about slope? Yes. It's almost better to use improper fractions when it comes to slope, because if I were to turn this into a mixed number, so let's do it. So 3 goes into 5 one time with 2 left over. If I wanted to recreate this, if I like pointed a line and it was like draw another point, I'd have to so we'll go up 1 2/3 and then over 3. It gets so confusing, and it's so much easier to keep it as an improper fraction, because remember, this is a ratio written as a fraction. This is not a fraction that we need to reduce, like it is, but it's a ratio first. It's a ratio first, which is a comparison between two numbers. When we get into mixed numbers, it's not really a comparison of two numbers anymore. It's just saying 1 whole and 2/3, which is not really the same thing. Next, 2 points. I'm going to determine if this is positive or negative first. This is a really steep downhill slope. So I'm going to look from left to right, and I see that it's going downhill. I can also go back up and look at my little picture, and I see that it's going downhill up there. It kind of matches. So I know that this is going to be negative. So let's do rise over run. And I'm just going to go ahead and put my negative symbol in here to start with. Let's find our triangle. Whoop, whoop, whoop. Okay, triangle. And then first, let's count our rise. Let's count our vertical space. I got 1, 2, 3. And then my run. Let's count my horizontal space. 1. So my m is equal to -3 over 1, or this one we're allowed to write as -3 because we know that every whole number has an invisible over denominator of 1 underneath it. And that's something that we know as Algebra 1 students. So my slope here is -3. Let's double check. It looks steep. It looks down. It looks like a black diamond run. Maybe a double black diamond. I realize this is yellow. You know what I mean. Okay. Number 7, another one. Positive or negative? This is going uphill. This is going to be positive. Okay, let's find my whoop, whoop, whoop. Let's find my rise over my run. I'm going to draw my triangle. I'm going to color my 2 points to make them a little easier to see. I'm going to do my rise. 1, 2, 3, 4. And then my run, my horizontal space. 1, 2, 2. Can this be reduced? Yes, it can. I'm going to divide by my greatest common factor, which here is going to be 2. So it's going to be 2 over 1, or m equals 2. That's not so scary, huh? Maybe it is still a little scary, and that's okay too. We'll do another practice one. So first, let's look at this one. I see positive or negative. Let's see. I'm going to look from left to right, and it looks like he is going downhill. He's shredding the gnar, as it were. I'm going to color in my points. I'm going to draw my little triangle. Make sure it has a little right angle here. I'm going to count my vertical space. 1, 2, 3, 4. So my rise is 4. And then I have 1, 2, 3, 4. OMG. What's 4 divided by 4? 1. So my slope is 1. And that one is really fun to look at too, because if you look at the graph here, we can see that every single point has a really nice spot on the graph. It is always on an actual point. There's none of them that are in between, like over here. This one's like in between, and we can't measure that super accurately, but this one, perfectly on the spot every single time, which is super fun about these one slopes. So we just go up 1, over 1, up 1, over 1, up 1, over 1, up 1. It's like perfect stairs at the perfect pitch. Nobody would be falling down those. That's just such a nice, I love when things work out nicely in math. Okay, we'll do 2 more, and then we'll wrap up for the day. So this one, positive or negative? Let's see. So I'm going to go from left to right. Am I rating the lift, or am I shredding the gnar? I am shredding the gnar, going downhill. I'm going to find my points that I want to use. I'm going to draw my triangle. I'm going to count my vertical space, my rise. 1, 2, 3. Then I'm going to count my run, my horizontal space. 1, 2, 3, 4. And we know that this is negative because we're shredding the gnar. So my slope is negative 3/4. Slay. Oh, that's steep. Would you want to ski down that? Some people might. That would scare me. Let's make sure this is right. So let's go left to right. Am I shredding the gnar? Am I riding the lift? I am going downhill, shredding the gnar. Excellent. I'm going to find my 2 points. Point 1, point 2. I'm going to draw my little triangle. I'm going to draw it a little nicer. Okay, so let's count my vertical space first, my rise. I have 1, 2, 3, 4, 5. I know that that's going to be negative. And my run, easy, is just 1. My slope is either 5 over 1, is either negative 5 over 1, or just negative 5. Because we're on Algebra 1, and we know that this can be reduced to negative 5, and we also know that we can put it back underneath, and it means the same thing. Great. That is all I have for you today. Let's review just a little bit. We talked about how a ratio is a comparison between 2 numbers. We talked about how a rate of change is a ratio that talks about how one variable changes with respect to another variable. We used the example of apples to bananas, and then we transformed those to talk about that relationship of the rate. We talked about slope. We talked about skiing on the mountains. We talked about how some slopes are steeper than other slopes. We used the word slantiness. We used the word steepness. And we used the words ratio of vertical change to horizontal change. We also used the words rise over run. We talked about how the slope is going to be the same on the same line no matter what you do. And we talked about how the slope is always written as a fraction in simplest form. We also talked about how the slope is represented by the letter M, and we don't totally know why. We talked about what a positive slope looks like, how we're going up the ski lift. We talked about what a negative slope looks like if we're going shredding the gnar down the hill. We talked about how a 0 slope looks like just walking on flat land, and we talked about how an undefined slope is we would need special equipment to climb that wall, scale that wall. We also talked about how a good way to maybe remember these is that a horizontal line looks like the start of a Z, and a vertical line looks like the start of a U. And then we practiced calculating slope by drawing triangles and counting spaces, and then putting those numbers into our formula as the rise is the vertical space and the run is the horizontal space. We talked about if it was going to be positive or negative based on these little pictures that we drew earlier. All right, great. Thanks for tuning in. Catch me next week, and we're going to talk about the slope formula, which is one of my favorite things to teach. So I hope this helps. Thank you. Bye.